I got some problems from 4.5. This is from the homework, so hopefully it'll help you out. If you haven't looked at it, or if you did look at it and you have some problems, we're going to look over those today to make sure we have a good understanding of that. I got some other problems too on a post-it note that must be good in my notes. So we'll go over those if we have time. That is the plan. All right, so let's talk about this first one. This is kind of what I used to intro us to quadratic inequalities. We're trying to figure out where is our function greater than 0 and where is our function less than or equal to 0. So let's talk about part A first. Where is f of x greater than 0? So how do we go about doing that? What are we trying to find? The x value is where y is what? Greater than 0. Good. So we're trying to find the x values. I like the way you worded it. The x values where y greater than 0. So that means it's where it's above the x-axis. So if we look at our graph here, it's above the x-axis here, above the x-axis here. I don't really show it very well. Let's just do a paintbrush. Here, here. Right? And so what are the x values? The x values are going to be from here onto the right, and from here onto the left, right? So where is f of x greater than 0? Negative infinity to negative 3, and union 3 to infinity. And we don't include the negative 3. We don't include the 3 because we're only talking about where it's greater than 0, not where it's greater than or equal to 0. Any questions on that? No. If you ever get tired of typing like the finding the infinity thing or the union thing in my math lab, just a quick little thing. You can do the, what's that? I forget. Nope, wrong slash. I always forget what the slashes are called. But you can use the slash like this and then type I and F and it'll put an infinity for you. Or if you type the slash and put union, it'll put the union for you. So just some quick things to help you out. It's the slash that's not on the question mark, the one above, like the enter key. I forget which one's called. That my computer science major. I always mix them up. Hey, any questions on that one? No? All right. Let's talk about where is f of x less than or equal to 0. So in that case, we're trying to find the x values where y is less than or equal to 0. And so we're looking where it's below or on the x-axis. So that's going to be, oh, give me a paintbrush. From here to here, including those x-intercepts. So the interval is going to be from there to there. And so what interval is that? Negative 3 to 3, and what symbol we're going to put on the ends, the bookend? We're going to put a bracket because it can be equal to negative 3 and it can be equal to 3 because it includes being equal to 0. Any questions on that? No. No. All right. Continue forth. So you got one here. I want to solve this inequality. I might just copy this one and put it on the next page of the other ones. like, here we go. Let's just do 3 at a time. So try out these 3. Remember, the first thing you want to do, make one side 0. And you want to figure out where it's equal to 0, and then work from there. That one's pretty much set up for you to begin with. You know, one side is already set to 0. That's good to go. I like that we have a positive a value, right? The a is 1 here, so that's good to work with. Sometimes I'll move stuff around. I think I showed y'all that last week. Move stuff around so that way the a value is positive, makes it a little bit easier. But the first thing we're going to do now, since it's already set up, is we're going to make it an equation. We're going to make it equal to 0. So that way we can find our x-intercepts, right? And so to solve this one, let's say we got a factor, and let's say it's going to be x minus 4 times x plus 3. The AC method, whatever method you want, but that would get you there. And so that means that either x minus 4 is equal to 0, or x plus 3 is equal to 0. And so x would equal 4, or x would equal negative 3. I always have them in the wrong order. And so that means those are intercepts. It's going to intersect the x-axis at x equals negative 3 and x equals 4. And so we're going to take that information, draw ourselves just a crude graph here. We'll say, well, this is where x is equal to negative 3. Remember, put them in the right order. And where x is equal to 4. I don't normally write the x is equal to, but I did there. Which way does this open? Up. A value is 1. 1 is positive. It opens up. So we know that our parabola is shaped roughly like that. One thing that helps people sometimes, and I wanted to bring this up the other day, is to kind of draw your parabola a little bit maybe flatter. This. Because if you draw the arms going straight up, it looks like something can be confusing what the x values are at certain points. So I've seen people do that in the past, and it helps them out. I don't do it myself. I'll try to do it. So we're trying to figure out where is it less than 0. That means it's going to be below the x-axis. So that's going to be this part of the graph here. That means it's going to be these x values between negative 3 and 4. And so my solution, is going to be from negative 3 to 4. Are we going to include the negative 3 and the 4? No, because there's no equal to stipulation on this inequality. And so we're just doing negative 3 to 4. Any questions on that one? All right, second one here. Set up for you as well already. We got x squared minus 5x is equal to, is greater than 0. So we want to know where it's above the x-axis. And so we're going to set it equal to 0, figure out where those intercepts are. To factor this one, you got to factor out a common term of x. So you're going to have x times x minus 5 is equal to 0. And so that means x is equal to 0 or x minus 5 is equal to 0, which leads me to say that x is equal to 5. Well, so our zeros, our x-intercepts are at 0 and 5. Let's draw that out. Oh, maybe not. There we go. Let's put 2 dashes for us there. And we're going to have 0 and 5. Make sure you write them in the right order. And we know it opens up. A value is 1. That's positive. So let's draw it like, not like that at all. Let's draw it like this. We're trying to figure out where it's greater than 0. Where is it above the x-axis? So it's going to be here and here. And so that means that it's going to be those interval of x values. That's why I like to draw it kind of wider and flatter, because it shows you that it keeps going towards positive infinity, negative infinity as well. So, what's my solution going to be for this one? Anybody got one? Negative infinity to 0 and 5 to infinity. And what are we going to put on those? Parentheses. Equal to. And don't forget the union in between. I think it allows you to type or as well. I'd rather use union. That's what union means, is or. This set or this set. Any questions on that? Any questions here? Didn't see any. Nope. All right, this last one. So this last one's not set up as of yet. We're gonna do a little bit of work, and I'm gonna subtract 8 from both sides. We'll get x squared plus 2x minus 8 is greater than or equal. Sorry, greater than or equal to 0. And we're gonna do the same thing now. Let's set it. Why wouldn't you include 5? So if this was greater than or equal to, then you would include the 5, because when it's 5 is actually equal to 0. When it's 0 is actually equal to 0. But we only want to know where is it greater than 0. So where is it above the x-axis? Whereas if I do it with include, that is where it is 0. That's where it's on the axis. Got it? Cool deal. All right. So we're going to set this equal to 0. We're going to x squared plus 2x minus 8 equal to 0. And after that, what's it going to be? X plus 4 times x minus 2. And so that's going to lead to two solutions of x equals negative 4 and x equals 2. Any questions on finding those? Kind of assuming everybody's got factoring to control it. Cool. So, give me a marker. There we go. Let's draw our quick little graph. We got negative 4 here, positive 2 here. Which way does it open? Remember, we're looking at this equation, the one with the 0. That a is positive. So it is opening up. Well, and we want to know where is it greater than or equal to 0. So that means where is it above the x-axis or on the x-axis. So we're going to include those points there. And so my solution is going to be negative infinity, negative 4, include the negative 4, union 2, including the 2, and 2 infinity. Remember, don't include the negative infinity and positive infinity. Always put parentheses on those. Is a value you cannot achieve. Any questions on that? Let's see what's next. I made these problems like beginning of last week. I don't remember what's up. If you want to at least do those. Yeah. Okay. All right, give these two a try. Yeah, 2x squared is less than 11x plus 6. You got to move stuff to one side, depending on which side you want. It's totally up to you. But remember, once you've got one side set to 0, that's when you start your actual work. That's when you start making your decisions. Anything for the second one, either move the 3x squared plus 4 or the 4x. So do you want to talk about that one a bit? So the first one, 2x squared less than 11x plus 6. I would recommend moving the 11x 6. That way you keep the a value positive. If you did it the other way, hey, it's fine. I just feel like it's easier to work with the positive a. So we're going to end up with 2x squared minus 11x minus 6, still less than the right-hand side, which is now 0. We didn't multiply or divide by negative, so the inequality remains the same. Okay? So now we're going to set it, excuse me, equal to 0. Find those x-intercepts. To factor that, we have a little bit more work, so it's going to be AC is negative 12, B is negative 11. When they're 1 off from each other, it's going to be 12, 1. I know that, but which one's going to be negative? Negative 12. And so we're going to rewrite that as 2x squared minus 12x plus 1x minus 6. And then we're going to factor it by grouping. We're going to factor, what can we factor out? 2x squared minus 12x? 2x. And we're going to have x minus 6. And we already got an x minus 6, so let's just put a positive 1. I'll move this problem again. Over there. And so what we end up with is x minus 6 times 2x plus 1. Oh, we got that. So if we solve both of those, we get x is equal to either positive 6 or negative 1/2. Any questions on that? So don't worry about it too much. I mean, we're not doing anything else with the fraction other than saying, okay, well, negative 1/2 is here and 6 is here. What is my graph going to look like? Well, it opened up. It opens up because a was positive 2. So my graph is going to look like this. And make it real wide so that way it shows what the x values are doing. And we want to know what? I don't even remember. We want to know where it's less than 0. Always use the one that you started out with one side equal to 0. So it's going to be less than 0. We want to know where it's below the x-axis. That is going to be here. And so my solution interval is going to be from negative 1/2 to 6, not including those values because it's no equal. Any questions on that? Great. Right. All right, let's look at this one. Same kind of situation we got going on here. I would move the 4x. That way you keep your positive a value. Let's see what we get. We get 3x squared minus 4x plus 4 less than 0. We got it set up now. Let's make it equal to 0 to find those intercepts. Once again, I'm going to have to do the AC method here. So that's going to be a positive 12 and a negative 4. I don't think anything is going to factor that now. 12 and 1, 2 and 6, 1 and 12, but let's say it's positive 12 and negative 4. I don't see anything. So if we can't factor it, what are we going to do? Quadratic formula. Square minus 4ac all over 2a. And let's look at the discriminant first. So that's going to be a negative 4 squared minus 4 times 3 times 4. Ooh, look at that. So 16 minus 48, is that right? Yep. This is going to be what? Negative 32, which tells me what? Those solutions. So that means I have no x-intercepts. So it never crosses the x-axis. We can still draw that though. That's my x-axis. It never touches the x-axis. Which way does it open though? It opens up, right? Because the a value is positive, so that means the whole thing is up above the x-axis like that. We can figure out what the vertex is if we wanted to, but hey, I don't really care. Really? For this problem, I don't care. Any questions on setting that up? If you had no x-intercepts and it opened down, it would all be below the x-axis. Okay. And so if you want to know where is it less than 0, where is it below the x-axis? Is it below the x-axis anywhere? No. So this would be it never goes forward. Any questions on that? I'm glad that was a problem with it there. I like that one. Any questions here? Because that was the whole reason I made this problem. All right, so for this one, it's already, one side's already 0, so let's set it equal to 0. And if we try to solve this, I'm going to do the square root method. You can do whatever you want. You can't factor it, but you can do other stuff. So quadratic. And when we try to take the square root here, remember this is going to be plus or minus. We get x is equal to plus or minus the square root of -4, which is not a real number. That means there's no solution, which means there is no x-intercept. Questions on that? Which way does this one open? Up as well. The a value is a +1. It's going to open up. Oop, green. That means it's going to be up here. Like once again, we can find that vertex if we want to, but we don't need it for this type of problem. We want to know where is that greater than 0? Where is that above the x-axis? Does it ever go below the x-axis? No, so where is it above the x-axis? Always. So my solution says it's going to be -infinity, positive. So that's the two types you can have where there's no x-intercept. If there's no x-intercept, usually it's going to be that there's no solution or all reals, -infinity or positive. Now if they put the where it's equal to 0, I guess that wouldn't matter. No, that wouldn't matter. Any questions on that? Because if you did put where it's equal to 0, I mean, it's always greater than or equal, so it really wouldn't matter at all. Thinking about it, right? All right, now it's time. Ooh, no time. And let's try to do at least that one. We're just gonna work them together and see how far we can get. This is the one I really want to focus. The other one's a word problem, which you can either figure out or ask me a question on. So, what is the domain of this function? So, if you remember domain, there's two types of restrictions that can happen that we talked about so far. Either your variable's in the denominator, and you want to avoid having the denominator equal to 0, or you have a variable under even root. That's what we got here, and you want what's under that even root to be greater than or equal to 0. So if we want to find a domain in this one, I want to know where is x squared minus 25 greater than or equal to 0. And so we're going to do the same thing we've just been doing. Just want to show you a use for it. Yeah, x squared minus 25, set it equal to 0, figure out my x-intercepts. That's going to be x plus 5 times x minus 5 is equal to 0. So x is going to equal -5 or +5. What's that? Oops, that is -5. Make sure you write them in the right order. Which way does this open? A is 1. It's positive. It opens up. So we want to know Where is this greater than or equal to 0? Well, that's going to be all along here, all along here. That means these intervals on the outside here. And so my solution, which is my domain, is going to be from negative infinity to negative 5, include the negative 5, union 5 to infinity, including the 5. It just can't be between negative 5 and 5. It'll be negative.